Hello, everyone. My name is Chang Zhang from the University of Hull. We have a very excited project to share with you. It is a cooling project for data centers. The title is a super performance dew point cooler for data center. We, University of Hull, we have been working with a number of partners, including the Environmental Process Systems and NPS Humber Ltd. We together, in the last few years, we have been developing a special dew point cooler for data centers to remove the large amount of heat and save loads of energy for the end user. And this project we have designed and constructed, installed, and also demonstrated this specific technology at the Hull City Centre in Yorkshire. It's called Maritime City Centre. As you can see from the right-hand side, we have a picture showing here where the white dash box is where the data center is. And we have developed and installed a very nice dew point cooler in here. And it actually saved a lot of energy, reduced carbon emissions for the site in terms of the cooling. And in this project, we have done site survey, designed the demonstrator, the dew point coolers. We built it and we installed it right here. And we have done long time monitoring. And this slide shows how it works and what happens in the future. If we go to the technology itself, it's actually pretty simple, but that's the beauty of this technology. It is use a specific heat exchanger on the left-hand side. We designed the heat exchanger to extract the heat, but also to retain the moisture level as almost the same as you have for the indoor environment. So you can reduce the temperature but also keep the moisture level almost the same. We don't add moisture into it, but we reduce it by water evaporation. The right-hand side, we made a simplified animation. We have servers on the left producing heat. You want that heat to be absorbed by our cooler. So the hot air returns to the cooler. It cools down inside of the heat exchanger while the water evaporates. Part of the humidified air and warm air exhaust into the ambient, and part of the product air, the cooled air, we supply back into the room. That's how the technology works. We have been developing this technology since 2020, early 2020, and we have run the monitoring from August to September, and the energy performance is very exciting. Before the project starts, you can see from the graph here, we have the average power used for the cooling in terms of kilowatt is around 30 to 40, 35. But once we use our technology, we turn our dew point cooler on, and the existing cooler just drops off. The energy consumption drops off from 35 kilowatts to less than 10. And actually, our dew point cooler is only consuming about 2 kilowatts of energy, and the rest of the blue area is the existing air conditioning running on standby. So by comparing, and this data is the monetary data, is the real life data we gathered from the site at the Hull City Centre. So the difference is significant, and we actually saved about 90% of energy and carbon emissions. And that, if you calculate in the annual carbon emission savings, it's over 70 tons equivalent of CO2 emissions. And that's a lot of money as well in terms of the electricity bill reduction, not to mention the electricity price will go up in the next few years. And this technology actually helps the client to save money and also reduce carbon emissions. We have been working with a number of technology developer and technology uptaker. And one of our partner is really excited in this technology, having been promoting the sustainable energy technology for over 25 years, he said, Mr. Zafar. And they are thrilled to see the demonstration work today. We actually proved that the technology works. And we will continue to develop this technology together with a number of clients and OEM clients as well. And we also, in this month, in November, I have seen the technology broadcast and marketing in a number of news and city councils are willing to use this technology in the future. So what happens after the base IAEA program? The first thing first is the demonstration is still running at this moment at the data center, and the clients at data center is more than willing to keep using the technology. So we will get more data and have more impact from the project. And also in terms of the technology itself, the university, the partners will be continuously working together to improve the technology, especially for the reliability, longer terms, and also marketing, and make the technology ready for the commercialization. A lot of things can be done in the future, and these things will be based on the learnings and the experience from the project. This kind of technology, the dew point cooler, can be used to a lot of buildings and spaces that require cooling and ventilation, including data centers. You have servers producing heat, or railway stations, you have machinery or indoor heat source, as well as greenhouse. You have the horticulture sector, where the greenhouses will gather the sun and create internal heat source, and you want to maintain the moisture level or CO2 within the greenhouse. That's a good way of doing it by using our dew point cooler ventilation. And also that can be made to industrial buildings. In the past few years, University of Seoul, we have done a test in the industrial buildings, and the result is very promising. Lots of spaces can be done, can be cooled with the new technology, and the university and the partners will be working together to make the research with impact. Thank you very much, and hope this will generate more collaborations in the future. Thank you.